Alright, so the interval is going to be given every single time in the question itself. You don't have to come up with the figures by yourself. And now let's start sketching. So here I have drawn the axis. So my axis is going to be, the horizontal one is going to be t, the vertical one is going to be f of t. And the interval is going to cover from negative pi until 3 pi. As I mentioned to you before, it doesn't have to be 1, 2, 3, 4, 5, and so on. You have to draw it in a way such that it suits the interval that is given in the question. Alright, so now let's start sketching. So here I have a function of f of t equal negative 1 from negative pi to 0. There's no t over here. Automatically, we know that this is going to be a function of a constant. And we have seen this before when I discussed with you the fact on 4.1. So how to sketch for functions. The revision, when you come across a function that is a constant, automatically that the gradient is going to be 0. So it's simply going to be a horizontal line at the number itself. For example, if I have y equal 3, so it's going to be a horizontal line at 3 because the m, it is not positive, it is not negative, so it's not going up or going down, so it's going to be a flat horizontal line. Okay, so that's why here my function from negative pi until 0, I'm going to have f of t equal negative 1. So let me put on the axis somewhere over here. Let's say this is going to be negative 1, up here is going to be 1. So when I sketch is from negative pi to 0, it's going to be f of t equal negative 1. So I am done with the first function. And the second function, I'm going to have 1 from 0 until pi. So this is where 0 until pi covers. Is going to be f of t equal 1. So that is how my graph looks like. And straight away, like after you have sketched whatever that is given by the piecewise function, you can identify what kind of function this is. Whether it's going to be odd, even, or neither. But just by writing whether it's going to be odd, even, or neither, you will get 1 mark for that. This is very clear description though. So you have like one line at the top, one line at the bottom. And if I were to start with this line, and if I were to reflect that twice on the vertical, on the horizontal axis first, I will get this line. And when I reflect that again on the horizontal axis, I will end up with this line right here. So therefore, straight away we know that this is actually a features of an odd function. Okay, so this is actually an odd function. Alright, so now don't leave your function like this. So this is not yet done. Remember, you have to fill it in all the way from negative pi until 3 pi. And we know the fact that in the question that the period value is going to equal 2 pi. So every 2 pi distance, there is going to be a new cycle. So that is why. So this is t equal to pi from pi until 3 pi. So that is going to be another cycle. So when I sketch, it's going to look like this. So this is going to be my second cycle. You just have to imitate the shape. Remember the concept of copy and paste. So the principal waveform is actually in the form of down and up. So I'm going to have down at negative 1 and up here at 1 from 2 pi until 3 pi. So that's how my function looks like, right? And of course, like if you have a jump like this, so at t equal pi, I have two values up here and here. I can also draw a dotted line. You can either just leave it blank like that, or you can also draw a dotted line. So it's up to you. Right, so basically, so from sketching the function, which is going to give you here 4 marks already, 3 marks for sketching, 1 mark for mentioning the fact that it's going to be an odd function. So we are done with A, so sketching the function. Now I'm going to proceed with B, and now we're going to start with finding the Fourier series. Alright, so before we start finding the Fourier series, so I'm going to start by finding my value of omega. So we know from the function t is going to equal 2 pi. So omega, the formula is given by 2 pi over t, which for this case is going to be 2 pi over 2 pi, and that is going to equal 1. That is my omega value. Alright, so now that I have my omega value, so I'm going to start with the first Fourier coefficient, which is going to be A0. So this is going to be the formula for A0. 2 over t, the integral from d until d plus t of the function f of t dt. Right, so now I'm going to start substituting. So I'm going to have 2 over 2 pi, and now my integral. So where do I get the value of d and also d plus t? So that is going to be from the question itself, right? So this value over here, so this is going to be our whole function of f of t, for which the lowest value of t is going to be negative pi. So this is going to be my d value. And the highest value of t is going to be pi. So this is going to be my d plus t value. So your d value and d plus t, it is always from the question itself, right? So now I can substitute the fact that my d value is going to equal negative of pi. My d value is going to equal pi for the function of f of t dt, right? And now I'm going to simplify this. So I'm going to write this as, when I cancel the 2 and the 2 at the top and the 2 at the bottom, I'll end up with 1 over pi. Okay, however, be careful when you want to substitute this, right? So if I were to substitute the integral from negative pi to pi of the function f of t dt, so there will be two integration. Why? Because you have to remember that from negative pi to 0, so my function is given by negative 1, and from 0 until pi, so my function is given by a value of 1. So therefore, if I integrate this way, if I substitute the function f of t, I will end up with the first integral from negative pi to 0 of the function negative 1 dt plus the integral from 0 until pi of the function of positive 1 dt. So that is why I'm not going to substitute the function f of t yet, right? So I'm going to do something else first. So what I'm going to do is, okay, so before I start doing anything and substitute f of t, from the function that we have sketched, we identify the fact that f of t is an odd function. And we know that if we integrate from negative pi to pi, an odd function, if I refer to the graph, so it's going to be from here to here, this is going to be my region. Notice what happened. So one is above the horizontal axis, one is below the horizontal axis. So what happened is that my integral is simply going to be 0. Remember, this is the property of the odd function. So that is why for this case, I'm going to have 1 over pi multiplied by 0. I'm going to have my a naught is going to equal 0. Why? Because f of t is an odd function, and I integrate from negative pi to pi. So they're going to be like one function at the top, one function at the bottom. They are symmetric to each other. So the integration is going to be 0. Remember, this is always the case when you have an odd function. Alright, so now that I am done with a naught, I'm going to proceed with my calculation with an, the next Fourier coefficient. So the formula is going to be 2 over t integral of d to d plus t. So f of t cos of n omega t dt. That will be the formula. Now I'm going to start substituting. I'll end up with 2 over 2 pi. So my integral is going to be the same as before. It's still going to be from negative pi to pi of the function f of t cos of n. So we already know the value of omega. So the value of omega is going to equal 1. So that I'm going to have cos of nt dt. Right? So we have substituted the value of omega. And I can simplify this a little bit. And before you start substituting f of t, so inspect the property first. F of t is an odd function from what we have sketched, and cos is an even function. And when you multiply on an even, it is always going to be odd. Again, if we were to sketch this function, we are going to end up with something that goes one region at the top, one region at the bottom. They are going to be symmetric to each other. And therefore, the integration of this is going to be 0, because we integrate an odd function. So that is symmetric. We know that it's symmetric because of the region right here. So we integrate from negative pi until pi. So therefore, it is going to be 0. However, let me put a note over here. So when you find the Fourier series of odd function, right? So for Fourier series of odd function, a naught and an, they are always going to be 0. So I put it over here. Always, every single time. If you sketch the function and you figure out it's an odd function, automatically your a naught and an is going to be 0. So that is why actually in your calculation, you don't have to show all this. You don't have to show this. You don't have to show this. I am showing you because I want you to know why does it become 0. It becomes 0 because of the integration of an odd function. But in your calculation, what you're going to do is, right after you have found what is going to be the value of omega, so you're going to write something like this, for example, that omega is going to equal 1. And what happened is that because this is an odd function, a naught and an is going to equal 0 because f of t is odd. Okay, you can simply write that, right? So now you're done. So meaning that when you have an odd function, all you have to do is calculate for the other Fourier coefficient, which is going to be Bn. So now let's start our calculation for Bn. Alright, so Bn is going to be given by 2 over t, the integral from d until d plus t of the function f of t. The formula is going to be sine of n omega t dt. Now let's start substituting. So I'll have 2 over 2 pi. Again, the d value and d plus t is still going to be the same. I'm going to have this of the function f of t, so sine of nt dt. Right, again, before you start substituting f of t, so check the property. So f of t is an odd function, sine is also an odd function, and we know that when we multiply odd and odd, it is bound to become even. Right, so now that I have an even function, of course the integration is not going to be 0. But the thing about even function is that we know if we were to sketch it, what happens is that they are going to be side by side. Like, I don't know exactly how does ft sine t looks like, but I know the fact that like one region is going to be on this side, one region is going to be on the other side, and they are going to be symmetrical. So one side is going to be from negative pi, the other one is going to be until pi. So instead of like integrating the whole region, what I'm going to do is I'm going to integrate only one of the region. And when I wanted the whole thing, I'm going to multiply by 2. So that is what I'm going to do over here. All right, so here I'm going to have 1 over pi. Now, my integration is supposed to cover from negative pi to pi. But when I only wanted to integrate half of the region is going to be only from 0 until pi. So that is why our new limit is going to be from 0 until pi. But remember, we wanted the whole region. So that is why you have to multiply by 2, right? So now we're going to start substituting f of t. Right, so my lower limit is 0, my upper limit is going to be pi, meaning that the value of t, it covers from 0 until pi. So if you have a look back at the function, I have two functions. So my first function is going to be -1, so the other function is going to be 1. So which one should I pick, whether it's going to be -1 or 1? So it depends on this interval. So if I wanted something from negative pi to 0, I'll choose this one. I'll choose -1, or if I want something that covers from 0 until pi, I am going to pick positive of 1. Right? And of course, for this case, because our integration covers from 0 until pi, so my function f of t is going to equal 1. So therefore here, I'm going to have 1 multiplied by sine nt, which is simply going to be sine of nt dt. Right, so see how it actually simplifies our integration. So now we don't have to longer we no longer have to deal with a negative angle. So now our angle is simply going to be 0. Remember, substituting a 0 angle is much easier than having to substitute a negative angle. You want to avoid that, definitely. Okay, so let's proceed with our integration. So here I'll end up with 2 over pi. So now I'm going to start integrating. When I integrate sine, it's going to be negative cos. I'll end up with negative cos of nt over n. And my limit is going to be evaluated from 0 until pi. Okay, and now all we have to do is we are going to substitute the value of t. First, we're going to substitute when t is equal 0. So t equal pi, we substitute upper limit first, minus when t is equal 0. So let's see what happened to our substitution. So I'll end up with 2 over pi. Okay, so when I substitute t equal pi, I'm going to have negative cos of n pi over n. Okay, and then this minus and this minus, so I'm going to have a plus, and then I'm going to have cos of 0 over n. So that's how it looks like, right? And now that I'm done with my substitution, I know that cos of 0 can simply be calculated by using your calculator, and cos of 0, the value is going to be 1. So therefore, and this n over here, I can actually pull it out instead of putting it here, because both of them consist of n. I can factor it out. I can write that this is actually going to equal 2 over n pi, so 1 minus cos of n pi. Okay, so that is how it looks like. And one thing about cos of n pi is that you can actually replace, so cos of n pi is actually -1 to the power of n. So let me explain to you at the end of this video, why is it that cos n pi is equal to -1 to the n. So let's finish this calculation first. I don't want you to get confused if I explain that in the middle, right? So let's proceed to this one first. Why is it, how are we going to solve this? We're actually about done. Okay, so basically after the integration, we have substituted the limit, so this is going to be the outcome. So this is what we got. So we have that our bn is given by 2 over n pi, so multiplied by 1 minus -1 to the power of n, because cos n pi is actually equivalent to negative 1 to the power of n. They are the same. When you come across cos n pi in your calculation, you can always substitute that as negative 1 to the power of n. And I will explain to you in a bit why is that so. Okay, so now I'm going to simplify this function right here. What do I mean by simplify? Okay, the thing about negative 1 to the power of n is that when n is an even number, okay, even number means it's a multiple of 2. So negative 1 to the power of 2, negative 1 to the power of 4, negative 1 to the power of 6, and so on. So negative 1 to the power of n is going to be 1. So it's going to be a positive of 1. And for the case that when n is odd, for example, when negative 1 to the power of 1, negative 1 to the power of 3, negative 1 to the power of 5, and so on, what happens is that your negative 1 to the power of n is going to be a value of negative 1. You can use your calculator for this. Remember, like when you have twice the negative, it's going to be positive. So that's why when n is even, so your negative 1 to the power of n is going to be 1. And when n is odd, your negative 1 to the power of n is going to be negative of 1. Okay, so that is why. So we can actually make a generalization of this function. So my function f of t, okay, so I'm going to make a generalization when n is even and when n is odd. So let's start when n is even and when n is odd. So we know that if this function over here, if this is even, so I'm going to end up with 1. So 1 minus 1, that is going to be 0. So that's why when n is even, so this function at the top right here, so it's going to be 0. But when n is odd, what happened is that, okay, should I actually, you know what, let me write that in full for the first one so that you can get the idea. Like when I do it next time, I'll skip it. Okay, so f of t, so when n is odd and n is even. Right, for the case is that for n is odd, so I'm going to have 2 over n pi. So this is going to be 1 minus negative of 1, because now this is going to be negative 1. And negative 1 minus negative of 1, that is going to be 2. So I'm going to have a 4. So I can write that for this case. So f of t is going to equal 4 over n pi, so when n is odd, right? So that is going to be for odd function. And for the case of even function, okay, I'm going to end up with 2 over n pi, 1 minus 1, okay? Because when it is going to be the case of even function, so negative 1 to the power of n, so it's going to be a value of 1. So this is what I substitute right here. Right, so and we know that 1 minus 1 is going to be 0, so that is why our function f of t is going to be 0 when n is even. So that is how my function looks like, right? So f of t is going to be 4 over n pi whenever n is an odd number, and it's going to be 0 whenever n is an even number. And from this, now that we already have all our Fourier coefficients, sorry, this is actually not ft, so this is actually our bn. Okay, so this is what we got from our bn. Remember, we are calculating bn. Okay, so now that we already know that a naught is going to equal 0, an is equal 0, bn is going to be given by this function. Now we are going to put into the formula of Fourier series. So at the beginning, I've given you this formula of Fourier series. So it's given by a half a naught plus sum from n equal 1 to infinity of an cos of n omega t, and plus sum from n equal 1 to infinity of bn sine of n omega t. Okay, and now because you have an odd function, so things are easier for us. The reason is that because a naught is going to equal 0 and an is going to be 0 as well, automatically these two terms are going to be 0. So we only have this term to fill in. Alright, so now all we have to do is, so we're going to substitute bn, and we know that bn is going to equal 4 over n pi. So with the condition, and n is an odd number only, or else it's going to be 0. So what we can do is, so I'm going to write that f of t is going to equal sum, okay, but this only applies when n is odd, okay, but it's going to be our bn is going to be 4 over n pi. So sine of nt, because we know that omega, the value is going to equal 1 from our calculation. But this is not yet our Fourier series, because we have to bear in mind that the value of n, you cannot change it. For the case of series, your value of n always start from n equal 1 to infinity. But how do we make n an odd number? Okay, there is a way. So the thing about n is that if I have n, okay, if I have some, so let me use another pen for it. If I have n equal 1 to infinity of 2n, automatically this is going to be a combination of an even number, right? When n is equal 1, so when I substitute right here, I'm going to have a 2, plus when n is equal 2, when I substitute right here, so I'll end up with a 4, and when n is equal 3, I'm going to have 6, and so on. What happened is that it created, when I have a function of 2n, so it created even numbers, okay? But whenever I have n equal 1 to infinity of 2n minus 1, so when n is equal 1, I'm going to have 2 minus 1, that will be a 1. When n is equal 2, so I'm going to have 4 minus 1, that is going to equal 3. So n equal 3, I'm going to have 6 minus 1, that is going to equal 5, and so on. If you notice, what happened is that this series, it created odd numbers, okay? So this one create odd numbers. So this one, it create even numbers. So that is why when you write the series in full, you have to write that from sum from n equal 1 to infinity, whenever there is n in here. So what you have to do is now you have to think the fact that now we have to make n an odd number. So that is why for this case, you can have 4 over 2n minus 1 pi, so sine of 2n minus 1 t. Okay, so that will be the outcome of this function right here, right? Because, and of course, if this is even, and you are going to substitute 2n wherever there is n. But when n is odd, you're going to substitute 2n minus 1 whenever there is n in the function, okay? So that is how it goes. So that is going to be our Fourier series. So this is going to be the end of the calculation. So this is very lengthy, but what I can promise you is that it's going to give you a lot of marks as well. So like for one calculation that looks like this could give you about like, I don't know, 13 to 15 marks. So depending on how long of the calculation it is. Okay. So I hope that, I know that for this one, it is not very clear yet. But as I show you more example, then you will get more idea on this. Okay, so I'll see you in the next.